Okay, today I'll be examining and going through a very interesting topic that's known as stoichiometry. Stoichiometry. This is the branch of chemistry that deals with both the and quantitative um, calculational aspects, calculational functions. And this branch of chemistry is responsible for measurement of the chemical phenomena. Okay, so I've got four kings of this field. The four books I've used in my life are close to my heart, and I've always used them whilst teaching and tutoring. The first one I'd like to talk about is um, the Chemistry Calculations by J.A. Hunt and A. Sykes. This book is lovely because I've had the textbook version of this book as well, and I believe you me, I've learnt a lot over the past 16 years. I've lost the textbook, and the textbook was a beautiful larger version, the larger version of the same picture, which is this picture is of sodium potassium tartrate tetrahydrate crystals that were taken through an X-ray crystallography picture, and they were then used as a cover for this one and the book. And believe you me, I've learned a lot of advanced experimental chemistry concepts from that book, and I love it from the bottom of my heart. So that's the first book. So coming back to the topic of stoichiometry, which is a branch of chemistry for qualitative and quantitative calculational functions, and it's the branch of chemistry that's responsible for measuring the chemical phenomena. So what is stoichiometry? The first one we'll talk about is is sorry. So this is um, sorry. Yeah, so the first one is moles, then moles and formulae, moles, masses of moles, gases, solutions, electrons, and then thermochemistry, then electrochemistry, then reaction kinetics. And some books will have radiochemistry aspects as well, nuclear chemistry aspects. That's part of Ramsden's book on calculational analysis, and I'll fetch that in a second. But so what is moles? Moles is responsible well, moles itself is the measure of how atoms and molecules are, but the branch of chemistry that's known as moles or stoichiometry, it deals with the quantification of entities, chemical entities, whether they are simple formulae, or they are in gaseous format or solution format, or whether it's electrochemistry or thermochemistry, Hess's cycle, Hoffman cycle, and then whether it's subatomic, as in Aufbau principle, Pauli's exclusion principle, or whether it's talking about Hund's rule. So in all of these conditions, when quantitation and qualitative assessment is required, we deal with the branch known as stoichiometry. And reaction kinetics is a huge expression of physical chemistry's usefulness in the current modern industrial development. So this is this book, and it's got exactly 8 chapters, and it's very, very useful for GCSE students. So the second book is a bit ancient, but bear with me. This is the calculations for A-level chemistry by the author who's also published the calculations for GCSE chemistry, Mr. Ian Ramsden, is one of my favourites because his books are very thorough, and they give you an in-depth, multifaceted, multivariate grasp on the analytical chemistry and physical chemistry. And just to mention with emphasis that these books have a very strong organic chemistry chapter as well. They've got a chapter on organic chemistry that contains the similar kind of questions that you find in the physical chemistry branch of reaction kinetics, thermochemistry, electrochemistry, liquids and gases and whatnot. So please be pleased about the fact that you are in safe hands when you're using this book. It contains questions from all the way to the struggling 70s and 80s exam board papers, and those questions are king because those were the hardest exam papers. The GCSE and A-level syndicate classes of 70s and 80s were far more learned than what we experience it now, and I have a first-hand experience of solving papers in the papers from 70s and 80s when I was preparing for my GCSE and A-levels in 2000s, early 2000s, so circa 2005 and then 2006. Circa 2004 and 6. So yeah, I love this book and I've used it a lot. And here you can see that the chapter's name is Equilibria, Reaction Kinetics, but it's using an organic chemistry example, and it's giving you an introduction on how to deal with quadratic equations when coming to the reaction kinetics for dissociation constants, acid-base constants and whatnot. So this is that. The third book is I used was by Jim Clarke, an unknown author in my eyes. He was not known to me because I was a fan of Ramsden and Sykes. But when I took his book and I started going through, he had chapters such as, he's got the basic chapters. Then he jumped over to thermochemistry. That was new to me, jumping over to thermochemistry. Then he had reaction kinetics, and the chemical equilibria was a good one. I learned a lot for my A-levels for this particular chapter, which is chemical equilibria, chapter 7, page 152. So I learned a lot, and the acid-base equilibria was fun to play with, and I did not like the chapter 9 because chapter 9, apart from partition coefficients, the other concepts are not explained thoroughly. That's just my take on it. You may disagree, you have the right to disagree. But one of the other chapters I enjoyed very much and eased my learning through was redox equilibria, and then entropy and free energy chain was quite a boring chapter. Now, it's just, again, in all these calculational books, you start off with the basics, 1, 2, 3, and then you jump onto gases and solutions, so quantitating the amount of reactants and products exchanged and converted and distributed in gas format, solution format. Then you jump over to thermochemistry, then you do orders of reaction, and then you do reaction kinetics. So this book is good because it's divided reaction kinetics in about 3 to 4 chapters. Then you've got electrochemistry, which is known as redox equilibria. Now this book makes redox equilibria part of electrochemistry part of equilibria, but in other books it's mentioned separately as electrochemistry, especially for A-levels, because for A-levels you need to specify you're dealing with electrochemistry. Then you've got, and it finishes off with entropy and a very boring chapter of thermochemistry. Now thermochemistry he's done here, but this is an extension of thermochemistry where he's dealing with a vague concept of thermochemistry. So that's that. Now, moving on to this This is the same book, but it's the third version, the fourth version. Sorry, I don't know why. Hang on. Yeah, so it's just that this is the purple version, the same version of the same book. Now let me get the other book that I've been using, which is from Ramsden. So bear with me, please. Hang on. No, this one